So the job of this first part of the system is to find things of potential interest in a fast, efficient, clean way, and then basically to push high quality triggers forward to the upper brain.
Hello and welcome to the
latest
Trend Detection
episode of the Trend
podcast powered by
Detection
Siemens.
podcast. I'm really pleased to be joined by my colleague, James Loach, who is a friend of the podcast. He's been on many times, but I think it's been a little while since you've been on, James, so welcome back.
Yeah, hi Noel. Yeah, very happy to be back again.
Fantastic. And today we're going to talk about industrial AI, which the term, if you listen to any or see any materials from Siemens, you'll know industrial AI is very important to what we talk about. We're going to go beyond the sort of marketing speaking as a marketer as well. We do talk a lot about industrial AI, but James is actually doing the real stuff and the real implementations of it with our customers and behind the scenes. So yeah, it's going to be a great conversation. But I guess before we start, James, it'd be good for you to introduce yourself to the audience and remind us what your role is in Siemens.
Yeah, no problem. Okay, so I'm head of research at Siemens Senseye Predictive Maintenance. That's a role I've had for many years, 8 or 9 years now, since this was a very small startup. My role, head of the research group and part of the product leadership team. So responsible for developing all of the algorithms, the analytics, and the conceptual structures that those things sit within.
Fantastic. Thank you for that. First of all, let's start with that term industrial AI and what it actually means in reality. So not that there is a marketing reality, but there's also what's happening on the ground. So what's your sort of perspective on that, James?
Yeah, I guess maybe I'll put across a very simple view of this. AI is obviously this sort of suite of technologies that we all know about. Industrial AI, is just applying all of those technologies within an industrial setting. This makes it automatically not one thing, right? There's all kinds of different things that AI is very suitable for, everything from supporting coding all the way through to agentic decision making or generative tasks or simpler things like summarization or having you mine things in disordered data, all of these different kinds of things. But those applications of the technology start in the industrial world all over the place. Okay. And it's a huge area of opportunities. And what everybody is working out at the moment really is how best to apply these technologies. What are the situations where it works really well? What are the situations where we have to wait?
No, I guess just to cover first of all, because we all know, and you'll know obviously better than most people, the explosion in terms of generative AI. But of course, Senseye, we talk about Senseye specifically, AI has been the backbone of Senseye from the beginning, right? So do you think it's almost been forgotten about these more traditional, I'm going to say traditional AI technologies? Has it been forgotten about in this new age that we're in at the moment?
Yeah, I don't know. It's interesting. There's a long history of using machine learning, which is what you're talking about there in the pre-generative AI period, to do lots of interesting tasks. And Senseye, for many years before generative AI, was doing things with this kind of technology. But there have always been issues with scaling, basically, right? Being able to use this technology for particular applications, but not being able to push it out at scale, right? Across applications or different machine types or all of that sort of thing. And one special thing that AI is letting people do, and definitely in the case of Senseye, is to take what now seem like sort of traditional technology as a foundation, and then using AI to make the most of the things that you were doing before, and in particular for addressing that sort of generalization problem or other aspects as well, communication of results and things like that. Yeah, but many systems do use a combination of these things. And Senseye also uses a combination of even older stuff, right? We have a set of statistical systems, we have a set of machine learning systems, and we now have a set of AI systems. And one thing which is nice about Senseye is that these things are quite complementary and work nicely together.
That's really well explained, actually, the sort of foundations of Senseye with AI. And what I'm wondering is, obviously, generative AI has opened a world of opportunity. So what was simply impossible all those years ago when you started at Senseye, which is now possible today?
Yeah, so Senseye has always been about trying to look at sensor data from all different kinds of sensors attached to all different kinds of machines and do that at scale over hundreds or thousands of assets and try to find things that the user would be interested in that essentially help them with their maintenance, right? So typically developing problems and all of that kind of thing, right? So traditional techniques, if you apply them well, do allow you to do the first part of that pretty well, right? Which is to be looking over all of this data identifying things, essentially really unusual things or things that seem to have some implication, triggering a system and getting those things to the user. But then it becomes very difficult. So we can, in the past, you're able to identify that a particular machine seemed to be having an issue, and we can describe what's going on. But it was very difficult for us to really say what that particular issue was. And we had to make best use of the techniques available to us at the time, which were things like mapping the data that we were seeing to matching the data before previous failures in the past, identified from maintenance management systems, these kind of techniques. But what generative AI really lets you do in Senseye is to take those triggers, so the understanding that there's something up, right? Pass that to a part of the system, which in our case we may touch on a bit, is highly agentic and very smart, that can take that trigger as an indication of what it is. There seems to be something going on, and then to call on all kinds of supplementary information about what it might be, everything from the documents to looking at images of the time series to actually getting stuck in and doing some data analysis and changing the view of the data, whatever, all of that kind of information, bring it together and confirm that there is an issue, explain to the user what it is with some kind of confidence, and go through and say what we think you need to do and what's likely to happen if you don't do it, right? And provide all of the evidence for that. So that last bit, completely unimaginable before generative AI. You would just be surfacing objects of context. So you'd say, oh, here's the thing. It's similar to that occasion where you had a bearing problem, or this kind of thing, right? But yeah, we can be massively more sophisticated now.
That's, some amazing opportunities, very much into the prescriptive side of things. So it's not just this is happening and this is what we spotted, but we suggest you're doing is stronger maybe than it was before.
Yeah, taking the super intelligences, which are now available for hire, and connecting them up to all of this sort of information that we have and ways of interacting with that information.
I guess to balance it up a little bit as well. So what areas are still, what challenges do we still have? What's just as hard as it was before, maybe that at the moment generative AI hasn't solved?
The way I like to look at this, we just described a little bit about how Senseye works, but many other systems have this same kind of form, right? Especially, I think, industrial AI systems, that you have some kind of live information about what's going on. This can be time series, different kinds of vibration data. You can imagine even images, video, whatever, right? You've got something which is information about what's happening. Okay. And then you have information about the setting. So like what the machine is, the history of the machine, engineering drawings, all of this kind of thing. Right. And so you're taking the data that you're seeing and you're trying to make sense of that data fundamentally with what you know about the context, all of that additional information. And I think ultimately what generative AI allows is to do that kind optimally, right? So given the data you have, given the context you have, what is the most clear and confident things that you can say, right? That are most useful to the user. So there's a sense in which you set up the system properly, you can solve that. But the situation that I guess Senseye is starting to touch, and I think many of these applications will, is you have limitations on that input information. So the AI is letting you do ultimately perfect reasoning over the input information, but your input information compared to the amount of information that's out there in the world is typically very small, right? And then this is ultimately going to set the limit. And there'll be a point where it makes no sense to keep upgrading the models in these kind of systems without doing anything about the information, right? And so there will be a lot of differentiation in systems in how they approach this problem of getting context. You need to get information about the machine, what the machines are doing, what's happened to the machine in the past, how the machine works, and specifically what it's doing now, right?
Yeah, and it's interesting because we, in our discussions before, I think we knew where this podcast was going to lead, and you mentioned context. The first mention with 12 minutes in, so I thought it was going to actually be front and center. But you mentioned it there about it's all very well changing models and getting better models, but if the context isn't there, so that what you're saying maybe, James, is actually that will become the competitive advantage. What context can you bring to these models for the outputs to be improved?
Yeah, I think so. And yeah, sorry, I could have mentioned context in response to all of the questions earlier, later question. But yeah, it's what you bring as an organization or the people developing the software to the software. And in the case of Siemens, you can think about all of this in collective industrial knowledge, not all of which is available to these standard foundation models. And then, all kinds of systems and tricks and techniques and ways of getting context basically out of users' heads, right? As we said, technical stuff about the machines and different kinds of data. And you can imagine, and it is now generative AI is also helpful to this, right? So again, it's become a very easy task, for example, to photograph nameplates on machines, pull the text out of that and use it, right? So that could be done at some level before generative AI, but stuff like this just becomes very accurate and very easy, right? But yeah, it is exactly as you said. I think this will be differentiate lots of these products, how they approach that context problem and data collection problem on the input. And then the second area really would be on the output. Yeah, how you're getting this stuff to users, how you're interacting with customers or stuff like that. Yeah.
And I think you touched upon the elements there, James, but maybe we could spell it out clearly from your point of view. What information would an AI system need to understand what's happening with a machine in an ideal world, which we're not, I know, but if we had every bit of context available, what should we be feeding into the system for it to provide the best output it can do?
Yeah, I think there's probably a massive difference here between what's sensible and what the perfect real world is. Obviously, in a real world, in a perfect real world, you're interested in the physics of things, right?
I see.
Complete detailed digital twins, right? To very great detail, so that the AI can essentially have access and know that information, and then also test its hypothesis against the models derived from that information. So really, of course, in an ideal world, this can be absurdly detailed and impractical, right? But if you're being more practical, yeah, you need to know the basic things, right, from what the machine is, right? Its make and a model and what it's doing, down through the details of its construction and deployment, different components inside it, all of that kind of thing. Yeah. And it's strange to talk about things as obvious as the make and model of the machine, but in many settings, yeah, getting this information users and getting it into the app requires work even for basic things. Yeah. And of course, you want to go all the way down into the physics and engineering as deep as you can. But yeah, so you want information at different levels about what the thing is, and then you need to know what it's doing, and then you need to how it relates to other machines around it and the processes, all this kind of stuff. And then you want to know the history of things, which is often extremely useful. And yeah, that's the kind of thing that's in maintenance engineers' heads. They get to know their machines over time. They understand their quirks. They know what they did to them last month to fix X, Y, Z, all of this stuff. Yeah, super useful, right? So it's the details of what is, and then over time, pushing that back with narrative histories of your assets.
I guess the elements. If we focus again, you mentioned that phrase, what's in the maintenance person's head. I guess a lot of that.
Yeah, we capture this the best ways that we can, and we're constantly thinking of ways to improve how we do this. And it's very tricky, right? So traditionally in Senseye, it has been, like you say, feedback on alerts, people telling us, oh, it was this and this was useful, this wasn't, all of that kind of thing. And then maintenance data, so the actual hard interventions on the machines. But it's very clear that maintenance engineers have a lot more in their head than that. Yeah. And a lot of that is implicit knowledge. It's a feel for things and what have you. And those things can even be things that they find it themselves difficult to express in words. But yeah, so it is as you said, and we're aware that this is only, as always, quite partial, and try to think of ways to get more information without people doing too much work.
Yeah. But of course, we should point out everything we've said, in an ideal world and what's practical and what's not. But you can get started with, there's a minimum you can get started with and still get impressive results, right? So there's probably a minimum, what's ideal, and then what's, when you said about going into the physics and that side of things, which is above and beyond. But yeah, there is a minimum starting point you can get started with.
Yeah, and generative AI helps massively there as well, because you have a system there which has this knowledge of the whole world and everything in it up to a certain level. Senseye itself is designed to produce interesting results out of the box, so to spot things happening that might be of interest to the user. Okay, just out of the box, yeah. And if you bring those two things together, you can immediately start giving a certain quality of prescriptive messaging. Even just knowing that it's a motor, the system can understand what the time series are, can see what's happening in them, and it knows all about motors and all about time series, and can start to say, yeah, at a certain level immediately, yeah, that this could be a bearing issue or something like that. And then its ability to do that, it improves as it gets a better handle on the specifics of your motor and what it's specifically doing. And like we're saying, its history and all of that. But very important to Senseye. There's a system that's designed to work outside the box, do something useful and valuable to you, and then try to be a sponge for additional information, additional context that helps to ratchet up this performance over time.
Exactly. Yeah, so it can build up that context over time, of course, as well. Yeah, that's what you're saying. And I guess as well, so we talked a little bit about the machine learning foundations of Senseye, but what I thought might be interesting to people as well, because again, agentic AI is a hot topic and a lot of software platforms in whatever industry are moving in that direction. But how does that sort of split, if we want to call it a split between the machine learning side and the agentic AI side, how does that, I guess, first of all, why is a split like that, and how does it work? How does it benefit the end user having that split? Maybe is a good way to.
Yeah, so the division you're talking there is quite a hard division in the Senseye system that we alluded to earlier. And we often talk about this as the lower brain and the upper brain, because in some sense it's mapping onto these different functions in animal brains. But the first part of the system is this statistical machine learning part. And that is designed to operate at massive scale, maybe monitoring tens or hundreds of thousands of time series at a customer and doing it every time these data points come in. So this is just basically a huge amount of data. And what you are looking for in that first part of the system is things of potential interest, basically. And it would work very well, to have an AI agent full of data analysis tools and all kinds of stuff, analyzing data from every machine at every single time point. But it would be prohibitively expensive to do that. So the job of this first part of the system is to find things of potential interest in a fast, efficient, clean way, and then basically to push high quality triggers forward to the upper brain, which is the expensive reasoning part of the system. And if we make that division very efficient, we only pass through very few signals into the agential part, and it means that we can spend a lot more resources on the agential part to make that very, very good. So there's this, it's basically a filter, to make sure that you only call the expensive agent when it's worth its effort to do that, and you get a return on the resources. And the benefit to user here is purely one of efficiency. That the intelligence, which is expensive, gets directed precisely to where it's needed and not wasted on lower value stuff, right? And the output of the intelligence in Senseye, the agentic part, is the thing the user sees, right? It's composing and structuring and writing the output. And we obviously want that to be as good as possible.
Yeah, so it's interesting we're talking about this lower half and upper half of the brain. And I was wondering, like both now and into the future, whether is it a 50-50, if we talk about percentage terms, like a 50%, both are equally important in what Senseye produces as an output. And is that the case now, and will that change in the future as well as we go to lead more into the agentic side of things? I don't know if it's, what you think about that.
It's an interesting question. I think with Senseye and systems like Senseye, you have to have both parts of the system. So in some way they're both necessary for the thing to work, right? So both 100% valuable. And then the tension there is, of course, this thing, Senseye wants to be extremely broad, looking across loads of data on lots of different assets, and then also be maximally deep. So for any particular situation of interest, go as deep into that, right? So if you try to be maximally broad and maximally deep, this becomes extremely inefficient, right? And ultimately unnecessarily expensive. And the division of Senseye gets you through this problem by essentially doing a lighter scan of this space, identifying only what's needed. You then go through to the second bit. And that is very important for systems like Senseye, which basically acting as agents for you, right? So Senseye as a whole is something that you task with looking at data from all of your assets all day, every day, and coming to you when it's got an issue. So there you have this problem to solve. Another class of application is ones where you're starting the conversation with a thing, right? And in situations like that, you can live entirely in the expensive agentic space, and you obviously don't need the earlier filtering thing. Okay, but applications like Senseye, you do need both. How this changes over time will be very interesting. And of course, we do think about this, right? We do wonder as model intelligence increases and costs drop, at what point it would be feasible to have the intelligence go deeper and deeper into the earlier parts of the system. So at some point, it will make sense to start replacing some of the statistic and machine learning things in the lower part of the brain with a little bit more intelligence. Okay, and we imagine winding this up as it makes sense resource wise.
Yeah.
But it's quite how this will play out. But certainly that movement is a thing in Senseye and would be a thing in similar systems. As that intelligence gets cheaper, you use it for more stuff, right? And push it more into the foundations.
And I guess that brings me to a more broader question. So when we think about AI, building systems and software themselves, and whether you're seeing, so I guess there's a lot of legacy software that's now, for the past few years, in fact, have been 2 or 3 years, been adding AI and generative AI functionality into their apps. But I'm wondering whether you're seeing a shift more towards, new systems that are just being built, AI native right from the start, rather than layering AI on top. I just wondered on a more broad view. Could be industrial AI, but it could be beyond that, of course.
Yeah, again, this is an interesting and difficult question. In terms of AI being added onto things, that can be added on in different ways, some of which make a lot of sense, and other things which are a bit more tokenistic, like the co-pilots being added to every system we encounter, right? They vary a lot in value. One interesting thing about Sense I've probably mentioned in these podcasts before is that we were quite lucky in the sense that we built the lower brain that I was just describing before generative AI happened, and then we had the opportunity to build out the upper brain. So you can look at Senseye and you can think we had an existing system, we added AI, but that's lucky in the sense that if you look at the system that gives you, it is the system we would have designed anyway, right? If we were starting from scratch, because for the reasons that I just described. So I'm just making this point that AI can be added on in ways that make deep sense and in ways which are more superficial. Okay, then in terms of AI for systems, I think the answer is probably no. I don't see a lot of super imaginative AI for systems out there. I think maybe this is a little bit of a disappointment because you imagine you have this massively new and different technology that we can all reinvent what apps are and do everything different with this kind of thing as a foundation. So you've seen a whole class of back and forth chat kind of applications that we're all familiar with, but with some with absolutely massive value, like the agentic coding tools and things. So we could say that's one category, but I don't know how many more there are than that, really, right? But it's odd. It's like we do talk about this a lot. We feel that there's something there, right? That these things can be imagined, reimagined, or done a lot better. It's close, and you can't, like a word on the tip of the tongue kind of feeling. But yeah, like a lot, not much. I think of huge interest is being revealed there at the moment. Yeah. The one thing specific to Senseye I will mention, but is in this category that we ponder about, is the ability of the AI to control the user experience and the user interface. So that's, to me, one area where I feel there will be a bunch of creativity. But you see the very beginnings of this in Senseye because the agent has a language that it's taught that it can write to determine what the user sees. So in terms of charts and other different UI elements and things like this, it kind of lay this out and has a certain amount of flexibility and things. But the models are capable of much more than that in terms of laying out web pages in applications. And I guess we wonder whether there's something interesting that can be done there to make that massively more custom and dynamic.
So I guess to summarize it, so you think there could be more opportunity in the front end of these platforms to utilize AI more? I know we talked about a lot of coding, but maybe is that leaning more towards sort of back end work, maybe not so much front end work? Is that maybe a way to summarize?
That's just one example. But I think that the thing is this, isn't it? Maybe I'm just being very unimaginative here. There are certain form factors that are interacting with computer modalities, right? And those are mostly the things that are. And then if you're thinking about these kind of applications, specifically industrial AI stuff, what options are there, right? There's charts and there's text and there's images and there's audio and there's these different things. And generative AI gives you a lot of flexibility in how you mesh these things together. But again, I think there's not been a blooming of 1,000 different new interaction paradigms that are interesting and exciting. It seems to me that there are a few, and yet this sort of more dynamic front ends or visualizations is one. But anyway, I think it's just an area where it's not been quite as exciting as it's first seemed like it would be.
No. But yeah, I'm sure it's the lag before the next sort of big acceleration and innovation. I guess on that note, as I pre-warned you before we started recording, we do have a lightning round coming up. But I guess before I'm going to ask that dreaded question, which I think particularly for AI, it's almost impossible question to answer. But with you being so embedded, obviously, in the topic, James, I'd be interested to get your thoughts on where you think things are going to evolve over the next. You can talk about the next 3 months if you want, the next year or the next 5 years. I'll let you decide. But just how things are going to evolve in this space.
Yeah, no, it's a very interesting and difficult question, and I can maybe lots I could say, but I just pick up some things related to what we've talked about. You imagine that these intelligences are going to continue to increase in power, and so the ability within these systems to do the inference and reasoning will tend to perfect, and then you're held back essentially by all the non-intelligence things, right? Which is all the human side of stuff, the organizational things, different kinds of data, to get access to different kinds of context, all of that stuff. And I think you probably see this, maybe we've seen it already, but we see it more broadly that, yeah, basically all the non-intelligent stuff, all the human stuff, the existing stuff becomes the bottleneck, right? Anything with intelligence it collapses, right? And then another aspect of this, which, again, it's not particularly original to say, but will be quite impactful, is the agentic side. So rather than just sort of reasoning over information in some sense, the ability to start going out and doing things in the outside world. And there are many systems around in the consumer space and what have you that allow these kind of interactions. But I think apart from coding, you've not seen a big takeoff because there's some sort of trust issues and, again, a harness sort of issues and, I guess, quality at some point, right? But eventually lots of these barriers will be crossed and you'll get a lot more interesting stuff on the side. And we haven't talked about that, but there is a situation eventually where Senseye is, with its lower brain, spotting something of potential interest, thinking through what that might be, and itself, by controlling whatever device is doing it, robot kind of thing, is to go out there and be actually doing the inspections and getting the information it needs, ultimately to make a decision about whether to stop, the line needs to be stopped or when, and what parts need to be bought and things like that. So everyone believes that latter bit I talked about, the agentic, robotic, automated part will come to pass. But I don't know quite the time scale there. Yeah.
No, yeah, exactly. And yeah, time scale is one thing, adoption, and we haven't really talked about trust as well. It's actually one of the first questions in the lightning rounds is actually going to be quite interesting around that, because obviously trust is key now, like trusting the output of a system. But for what you're talking about, which could be, like I say, it's difficult to put a date on it, but where you'll talk about tasks being automatically completed, right? That's a new level of trust required, right?
Yeah.
Beyond where we are now. So let's move to the lightning round now. So like I said, 3 questions. Past guests have taken different approaches to this. So they've either said the one-word answer, which a lightning round suggests, or they've got into a little bit more, provided more context, that word again, provided more context about why they've answered it. So we'll see how we go. There's no real rules around it. But so the first question, so for industrial AI, which matters most? Is it the model, is it context, or is it trust?
I had to say, I would say it's the model, right?
I thought you might.
What everything else builds upon. But of course, the real answer is they all matter.
Yeah, I know. That was a tough one. But yeah, I did suspect model might be your...
But that's the foundation, yeah.
Exactly. And then, so that we've just talked about this now, but the future of maintenance. So is it predictive, prescriptive, or autonomous? And again, I think I know your answer.
These are all odd things. Maybe we could say a lot about this. But what is that? So ultimately, the future is autonomous. Okay. The other things that you talked about in our world, they're mixed together, I think. We mainly think of things in terms of attention management, spotting interesting things, providing information for people to make decisions. And those decisions can be today and very quick and reactive, or they can just automatically be long term. So there's a sense in which I think that division, predictive and prescriptive, there is a little bit soft in certain ways. Yeah, anyway, I'll stop. It's not a lightning round style answer, is it? But
no, but don't worry. Many before you have chosen a different route. I should change it to something else than lightning round, but it's all good. Oh yeah, so the final question. So one, we're going to talk about industrial AI. So one industrial AI capability that's overhyped and one that's underrated.
I don't know that I can answer that question, right? Maybe I'm not connected enough with the hype about industrial AI things to have a good sense of that. Yeah, maybe the classic answer would be it's the same thing for both, right? Which is agents. And then the difference there is on different applications and different timescales. Maybe for certain applications, it's somehow massively overhyped for what it is. And then, other applications underappreciate how powerful. So maybe that's a cop-out answer. But
no, it's good. It's whatever comes into your mind, first of all. And you haven't been shown these or shared these before, so I appreciate that as well. So that's fine. That's all good. Okay, so that brings us to the end, I believe. Thank you, James, for joining us today and sharing your views on where we are today and into the future. It's been great having you on the podcast.
Yeah, no, it's good. It's nice to talk to you. Yeah.
And I'd like to thank everyone out there, wherever you are, for listening to this episode. We'll see you on the next one. Thank you very much.
Please like and subscribe on all major podcast channels. And to find out more about Senseye Predictive Maintenance, go to Siemens.com.